Good morning, good afternoon, good evening. This is Professor Sistrunk and I'm reaching out to the student body. Okay, students, we have another lab here that I want to explain because I want to give you some clear understanding of the labs that's about to come. These labs are going to begin to shake you up, make you a little nervous, but I want you to get focused on understanding why you're doing what you are doing. If you notice in this particular packet tracer, it says observe traffic flow in a routed network. Now, what do that mean? I want you to start thinking about the title, the objective, and a scenario background. Why are you doing what you are doing? Now, I had a couple of students reach out to me and say, Professor, I'm unclear about this lab. And yes, it's a little trick in there. It's a little trick, but it's a reason. In IT departments, the one thing we count on workers to do exactly what we want you to do. Your manager gives you assignments. They expect you to do those assignments without questioning, because they know when you start questioning the work, that's when a real problem happens. We don't want problems. like some people say, I want problems. No, we don't want problems in the IT department. So this particular lab had a little trick. It was supposed to be or have you focus on one specific thing: traffic flow, nothing else. But it wanted to show you how to do it. If you look at the objective, it says observe traffic flow in an unrouted LAN. Reconfigure the network to route between LANs. Observe traffic flow in a routed network. The first one is a LAN. This is nothing but a LAN network. That's it. I'm going to move this out the way. This is a LAN network. That means you have what we call an edge router here. That edge router is in a critical position because it has become a bottleneck. Meaning if someone destroys that router, the whole network is in jeopardy. So we want to show you how this is not the way networks should be set up. Now, you can do it if you're in a mom and pop network, but in the real world, corporations, and just think about it. You see 1, 2, 3, 4, 5, 6 PCs, but in reality, it's hundreds of PCs connected to these switches. Okay? They say 150. But they task you with the job of making the network bigger. Before you jump in and work on any network, you should take a look at, focus on the network at hand. So they wanted to make sure you understood this network. Now, without going through the background and getting straight to the nitty gritty, you were to clear the cache, the ARC cache at sales 1. So they wanted you to go here and learn how to use ARP. That's all they wanted you to do. Learn how to use this command called ARP, A-R-P-A. And that was it. Now you have another tool in your belt. Think of all these commands as tools. You know how a carpenter walks in your house, he got this belt on with all these tools? That carpenter is proficient in doing the work. He knows the right tool to use. You have another tool. It's called the ARC command. Now, if this had data running through it, going from one location to the next, all you had to do is replace this A with a D, which you know because you have worked on this project. Now, once you did that, I will tell you, go and take a look at the IP address. You can click on this right here and see that it's a 4, or you could go right here, close this, and click here and see that it's a 4. So it's two ways to look at the IP address. IPv4 192.168.1.4. So you see that IP address. Now, it wanted you to go from there to actually click on the simulation mode button. So I'm gonna close this and come right over here. This is real time. What you see on the screen is real time. I know you know it, but I'm trying to show you something. This is real time. But if you click in simulation, this here allows you to see the packets flowing. Do you know, being a network administrator, a network engineer, that's one of their primary jobs, to make sure whatever you send through the network get from point A to point Z. Just that simple. And when we have a problem, they step in and find out, troubleshoot what the problem is. And that's what you're aspiring to understand what could be the problem with these particular packets. Okay, so let's move on. Let's not slow it down. I know my stories get carried away. So it wanted you, after you got in simulation mode, it says open the prompt in Sales 2. So I'm gonna come to here, Sales 2, open this prompt, and then I'm gonna go to desktop command prompt. Okay, now once I open that prompt in Sales 2, it said, and then enter ping command followed by the IP address. So we know this is ping 192.168.1, if I'm doing it right, .4. That's the ping command. Now, once it says here, and then enter the ping command followed by the IP address in Sales 1. Use the capture command. So I'm gonna hit enter. Then I'm gonna use the capture command over here, and you see that if I hit capture again, packets are moving through the network. That's what this whole project was about. It wasn't about getting 100%, like I had to explain to a student. It was about you understanding how traffic moves through the network. And as you see, this is one of the most important things. That packet went to everything in the network. Do you know how slow your network would be if that continued to happen? Can you imagine 150 PCs, then 200 PCs, then 300? You have people sitting around talking about, what's wrong with the network? Okay, I'm getting a little bit carried away, but they would, because I've been in those days and those times. Okay, but let me move on. I digress. Okay, so now that we did that, we sent the packet where it should be. Now, they had a bunch of questions in here they wanted you to ask and all that, but it wanted you to capture one of the packets so you can see the information in there. So you can see the MAC address and you can see all this information in here. That's what network administrators focus on. What's going on? What's happening? Why is it this packet getting from one location to, you're following the traffic. Now, I just clicked any old packet. They had a specific packet they wanted you to click, but I just clicked any one. But that's what they want you to know. What's happening in here? And let me tell you something that's critically important. What layer is this work happening on? See, you gotta remember these layers. For those of you who haven't taken the time to memorize the layers, the OSI model, go back, memorize that, okay? It's important. If you went back, you would try to read them. Well, let's move on. You're getting tired of that. But that's the important thing. They wanted you to know what layers this information was on. Okay, so this is the OSI model. You have packets here, you have PDUs here. This is information you should know about a packet. Now, when you go to the higher network classes, we're gonna dig deeper into this, but right now, just make sure you, well, the OSI model, make sure you know, but the rest, we'll dig deep into. Now, you can see that you can just continue to see how these packets are flowing, but this is a slow process. Now we're gonna go to reconfiguring the network to route between LANs. So you're gonna reconfigure this network. I'm gonna go ahead and close that. Now in this particular section, it wanted you to take cables from one part of the network and take them to another part of the network. So, for instance, this cable here, right? Let me stop that so we can stop all that traffic going on. This cable here wanted you to take this and bring it up to the edge network, right? Let's see if the edge don't accept it. What's going on, edge? And once we get to the edge network, it wanted me to do that one, 0, 0, 1/0. Okay, then it wanted me to take this particular cable and go back up here and get the other one, which is 2. Okay, now this is a real world scenario. It's not completely real world scenario, but it's close to it. Okay, in ideal, we still wouldn't have a bottleneck, and as we move on, you're gonna learn what a bottleneck is, because if someone destroy that router, we're in trouble. We have multiple routers there. And I'm gonna get off that because that's taking you a little deeper than you should be right now. But anyway, but still, this here is where we should be, right? You can see this right here. Now, I'm not gonna fast forward anything, but what I'm gonna do is, I wanted to fast forward, but I said, no, I'm not gonna do that. But anyway, you see, I just went ahead and did it anyway. I just can't look at a network that's distressed. Anyway, moving right along. Let me stop. So now what I want to do is this. I connected all the networks to the right place. And it says, what is the IPv4? What IPv4 network assigned to France is? Now, those questions I'm going to let you answer and all that. But the point is now to look at traffic flow as it go through. So it says return to the command prompt in Sales 2, and we're going to do another ping. It says verify the op cache first. Let's go to the op cache, see if we got it in there. ARP-A, and you can see now it's an ARP cache. It's got the IP address in there. It's got the physical address, and you know the physical address as what? Of course, the MAC address. And then it's saying it's dynamic, meaning it's automatic. Okay, but what you also it says here, ping sales 2 again, ping sales 1. So I'm gonna go ping sales 1. Since I already know the IP address, I'm gonna hit enter. So now I'm gonna come over here and watch how the traffic flow. I'm gonna go ahead and click it here. Now look at how traffic is flowing now through here. Going to the router, and the router saying no. But look at what's happening. It's keeping the traffic only in this location. It's not allowing it to go through the entire network. So that was the purpose of this lab, to keep the traffic in one location instead of going around to multiple locations. So now the network is no longer moving slow. That's what this whole assignment was about. Think about it. And I didn't answer all the questions and do all the other stuff, but the whole purpose of this lab, which, let's bring this back up, which had to deal with packet tracer, observe traffic flow. It's not for you to get 100%. Now, some students went here to check results, and when they got here, they said, hey, professor, some things in here is not working. So now you see I got 1, 2, 3, 4 arrows. That wasn't the purpose of this lab. And I know you want it to be the purpose. You're looking for it to be the purpose. Let me shut this down over here. You want it to be, and you're looking for it to be purpose, but that's not the purpose. Oh, don't do that. That's not the purpose of this lab. This lab was simply for you to be able to demonstrate traffic flow. Now, most of you got total credit on it. I gave you total credit. But that was the purpose of this lab. If you have any questions about this lab and other labs, I got one more I'm going to show you. and just reach out to me like the other students did. When they was curious why I'm not getting 100%, they reached out to me. It wasn't for you to get 100% because you can't deal with routers right now. You don't know how to configure routers at this point. It was for you to understand how traffic flowing. And you can see right now, traffic is flowing the way it should be.